Hi young friends, welcome back to C-Level Physics. So in this video, we are going to discuss two advanced numericals based on oscillations of simple pendulum. Okay, here first sum. Two pendulums A and B of length L and L by 4 released from rest from the positions shown in figure. See here we have two pendulums A and B of length L and L by 4. So both are released from the both sides of vertical as shown in the figure. The same angular position. See here theta leftwards, here theta rightwards. So theta angular position remains same, but both are released from either side of the vertical as shown in figure, right? So calculate the time when the two strings become parallel for the first time. So when both are released from their usual positions like this, so both will oscillate like that. So now what is the minimum time taken by them to come parallel to each other? That is the question, right? So if you want to get that minimum time, we have to know time period as well as angular frequency. What is angular frequency? And see the solution. Angular frequency, otherwise time period, Ta equal to, we know that 2 pi root over L by G. Ta, time period of oscillation of pendulum, A equal to 2 pi root L by G. L by G, right, implies omega A equal to 2 pi by Ta. That is 2 pi by T in the sense root G by L. That's all. So in the same way, what is the period of oscillation of pendulum B? That is Tb equal to Tb equal to 2 pi root over, what is the length of pendulum B? That is L by 4. So instead of L, take L by 4 divided by G. That is uh, implies 1 by 2 into 2 pi into root L by G. So implies omega B equal to, what is omega B? 2 pi by Tb. That is 2 pi by Tb. That is 2 pi by Tb in the sense that is 2 root G by L. 2 root G by L. See here Tb equal to 1 by 2 into 2 pi into root over L by G. Implies that so omega B equal to 2 pi by Tb, that is 2 into root G by L. So that is twice that of angular frequency of pendulum A. So here angular frequency, otherwise angular speed, is more for B when compared to A. So it moves faster than it makes oscillations faster than pendulum A, right? So that's how we can get omega A and omega B. Now the oscillation of either pendulum can be shown on the same circle as shown here by taking projections, right? See, this is what circle with two normal axes, xo, x dash, y, o, y dash, right? For example, this is the position of pendulum A initially at t equal to 0. A is somewhere here. A is somewhere here, right? Somewhere here. Now when both come parallel to each other first time, let this will be the position of the pendulum A, right? Yes, this will be the y projection at t equal to t, like that. So it is going to oscillate that way, but projection, on taking projection on circle, we can have diagram like this, right? Okay, now this is the amplitude. Now what is the phase acquired? If I take positive axis as the reference, now this will be the phase acquired by the pendulum A, pi 1. Pi 1 is the phase acquired by pendulum A, right? Now at t equal to 0, this negative axis, let me say that negative axis is the position of pendulum B initially. At t equal to 0, this will be the position of the particle, position of pendulum B, for example. Now in the same time it oscillates like that, but its projection can be taken like this. See here, as angular frequency or angular speed of B is more than that of A, So it moves like that and reaches somewhere here, the same level as that of A, such that projections are coincided like that. See here, this is the position of the particle B at t equal to t. So this is the position of particle at t equal to 0. This is the position of particle at t equal to t. Now what is the phase acquired by that pendulum B with respect to lower, that is negative axis? Here as far as A is concerned, positive axis is the reference, but as far as B is concerned, negative axis is the reference. So that's why here this will be the phase acquired by B when both come parallel to each other initially, right? Now by symmetry, see here, as both come parallel to each other, they should have same projections on above the x-axis, otherwise on y-axis like this. See, if I take a normal like that, see both are having same projection, but they differ in directions. For example, this is in second quadrant in anti-clockwise. This also in first quadrant in anti-clockwise, but quadrants are different even though both are having same projection. See here, as far as B is concerned, its projection increases like that. As far as A is concerned, its projection decreases like that. See, both different not in projection but the direction of projection like that, right? See here, for B projection increases, for A projection decreases. That's why here phase acquired are in opposite sense. Why? Because here also you can realize that. See, this is what vertical. With respect to vertical, see here, angle made by string B is like this, anti-clockwise sense. But angle made by A with the same vertical, this is clockwise. So they different sense of angle. So likewise here also, they different sense of phase acquired also here. See, this is, if it is positive, this will be negative like that. Okay. So by symmetry, as A and B are above same level, at same level above x o x dash, therefore by symmetry, if it is pi 1, this one also pi 1 like this one also pi 1. Why? Because both are at same level above x o x dash, that is, this is pi 1, this one also pi 1, right? Now how to get time here? Time means t equal to relative phase divided by omega relative omega otherwise. So relative phase angle acquired by A and B divided by relative angular frequency acquired by A and B. Relative. Why? Because here we don't have perfect values for pi 1 and pi 2. What is pi 1? We don't know in number. What is pi 2? That also we don't know. But pi 1 plus pi 2, see here, pi 1 plus pi 2, 180 degrees. From here to there pi 2, here to there pi 1. So pi 1 plus pi 2 equal to 180 degrees. So we came to know that pi 1 plus pi 2 equal to 180. That's what, in fact, not sum, that is relative. Why? Because pi 1 and pi 2 are not in same sense. Pi 1 is with the positive axis, but pi 2 is with the negative axis. That's why they are different sense, right? So therefore pi relative equal to, right, that is pi 1 minus of minus pi 2 divided by omega relative also in opposite sense. Why? Because see, A and B are lying both sides of vertical but moving in opposite sense. That's why omega also different. So omega A minus of minus omega B, that is t equal to pi 1 of minus of minus pi 2 means pi 1 plus pi 2. Pi 1 plus pi 2, that is pi 1 plus pi 2 divided by omega A plus omega B. That is t equal to pi 1 plus pi 2. What is pi 1 plus pi 2? So from the diagram it is clear that pi 1 plus pi 2 equal to 180. That is pi radian divided by omega A plus omega. Omega A means root g by L. Omega B means 2 root GL. That is omega A plus omega B. That is 3 root GL. So 3 root G by L, not GL, that is G by L. So this is the time, minimum time in which both pendulums come parallel to each other. Okay, right? So this is the answer for the given question, right? Now second model sum, that is figure shows two simple pendulums A and B which are projected with speeds v1 and v2 at t equal to 0 from the positions shown below here. See here you have two pendulums A and B of length, same length L, right? So both are projected from these positions. Here it is string making an angle alpha with vertical. Here the string making an angle beta with vertical like that. So it is projected towards the main position, but here it is projected away from the main position like that. Okay. So here it is pendulum A, here it is pendulum B. Now these two are projected with the speeds v1 and v2 at t equal 0 from respective positions as shown in the figure. Now question is to find the phase difference of two pendulums. See here, it is projected towards main position, means its displacement gradually decreasing, but here it is projected away from the main position, so therefore its displacement increases, right? Now what is the displacement? Now see here it is displacement, say x1, here it is x2 for example. Now what is x1 here? X1 in the sense alpha equal to x1 by L implies x1 equal to L alpha. Similarly, beta equal to x2 by L. Beta equal to x2 by L implies x2 equal to beta L. So x1 equal displacement of pendulum A equal to L alpha, displacement of pendulum B equal to L beta. L beta, that is L beta. L beta like that. So these become projections. If I take the oscillations of both pendulums on the same circle, these two terms become projections, respective projections like that. Okay. Now, what is the amplitude of both pendulums here? We need to find amplitude. If you want to get phase difference between these two, we should get amplitudes, right? Now what is the amplitude? Now what is the angular frequency before that? See here, both are having same length. Angular frequency in the sense, of course, length is same. Length is same. Now time period is same. That is t equal to 2 pi into root over L by G. Implies omega equal to 2 pi by T. That is root G by L. That's root G by L. So for both pendulums, omega equal root G by L. Root G by L. That's all. Both are having same angular frequency. Right? Now, how to get the amplitude for both pendulums here? Here, amplitude of oscillations not given. So we need to find amplitude if you want to get the phase difference. Right? Now we know that, see the solution. We know that V equal to omega and root over a square minus x square, right? So we are having displacements x1 and x2. We are having omega also. So if you want to get amplitude, of course we have velocities also here, right? So V is known, omega is known, x is known. So what is a square? Means V square by omega square equal to a square minus x square. Implies that x square equal to v square by omega square plus x square equal a square, that is a equal to under root like that. So a equal to v square by omega square plus x square, right? So coming to for pendulum A, for pendulum A, so A1 equal to V square by omega square. V square means what? V1. That is V means V1. So V1 square divided by 1 by omega square. What is 1 by omega square? That is L by G. That's all. So V1 square into L by G. On taking square here, omega square equal to G by L. But here 1 by omega square, that is L by G. So L by G plus x square. Now what is x here? For as far as a is concerned, x becomes x1. That is x1 into L alpha. So x square means L alpha whole square. That is L square alpha square. L square alpha square. Okay. So this is what? Amplitude of pendulum A. Now what is the amplitude of pendulum B here? Amplitude of pendulum B, that is A2 equal to, for pendulum B, so A2 equal to, similarly A2 equal root over V2 square, that is V2 square into 1 by omega square, means L by G, into L by G, plus x square. X means what here? X2, that is x2 means L beta, that is L square beta square. L square beta square, like L square beta square. Now we can represent the oscillations of both pendulums on the same circle like this. Same circle with the two mutually perpendicular axes. See, this is what XO x dash, XO x dash, YO y dash, right? Now see, the displacement of pendulum A decreasing as it is moving towards the mean position. So that's why if X is the reference, now A at a given instant, A is somewhere here, for example, this is what A, right? Now what is the projection on y-axis here? This is the projection. Now projection in the sense displacement. Here it is displacement, that only becomes projection on y-axis. That is x1. What is x1? L alpha. From here to there, L alpha. Right? Now as far as reference axis is concerned here, that is, this becomes x is the reference axis. This is what? Pi 1. Phase acquired by pendulum A. Phase acquired by pendulum A. Now, what is this angle here? For example, gamma 1, for example. What is gamma 1? Gamma 1 means what? See here. So, this is what? If I close this one, this becomes gamma 1. Gamma 1. Angle gamma 1. Okay. Gamma 1. Now, what is this radius? Radius in the sense amplitude. As far as A is concerned, pendulum A is concerned, this line represents amplitude. What is amplitude? A1. A1. So this is what? A1. Right? So sin gamma 1 equal to what? Opposite side by hypotenuse. That is L alpha by A1. So L alpha by A1. L alpha by A1 like that. Okay. So implies gamma 1 equal to sin inverse L alpha by A1. Sin inverse L alpha by A1. Right. So in the same way, now as far as pendulum B is concerned, see its displacement increasing. Why? Because it is projected away from the main position. So displacement increases in the sense its projection on y-axis increases. Suppose B is somewhere here. B is somewhere here. See, if I take diagram like that, this is what B is somewhere here. Now XO x dash is the reference, right? Now B is somewhere here. This is what? Amplitude A2, this is what? A2. Now this total becomes pi 2, right? This is what? Pi 2, phase acquired. Okay, pi 2, phase acquired. Okay, pi 2 here. Now if I take normals onto x and y axis, see here we have two normals. Now what about this angle here? This is gamma 2 otherwise. Gamma 2. Here it is gamma 1, here it is gamma 2. Now what is pi 2? 180 plus gamma 2. Here what is pi 1? That is 180 minus C. This line makes an angle 180. that is pi 1 in the sense 180 minus gamma 1. Pi 2 in the sense from here to there, pi 2 equal to 180 plus gamma 2. Right? So this amplitude is nothing but A2, A2. Now this projection is nothing but x2, that is L beta, L beta. So as far as oscillation is concerned, x2 displacement of B, pendulum B equal x2 equal LB, that itself projection on y-axis. See, your projection increases, means the displacement increases in the sense projection increases here, as it is under third quadrant for anti-clockwise revolution, right? So projection for B increasing. Now what is the projection here? L beta, L beta. What is the amplitude A2? What is the angle here? Gamma 2. So sin gamma 2, opposite side by hypotenuse, opposite in the sense L beta. So sin gamma 2, as far as second diagram is concerned, sin gamma 2 equal to, see here it is gamma 2, sin gamma 2 opposite side by hypotenuse, opposite in the sense L beta. That is L beta by hypotenuse, means hypotenuse in the sense here too, L beta divided by hypotenuse here too, implies gamma 2 equal to sin inverse L beta by A2 like. So we can substitute A1 and A2 also here. Now what is pi 1 and pi 2? See here pi 1 and pi 2. Pi 1. See pi 1 in the sense 180 minus gamma. So phase acquired by pendulum A, that is pi 1 equal to 180 minus gamma 1. That is pi minus gamma. That is pi minus gamma 1 in the sense what? Sin inverse L alpha by A1. So in the same way, what is the phase acquired by second pendulum B? That is, see here pi 2 means here to there, that is 180 plus gamma 2. That is pi plus gamma 2. That is pi plus gamma 2 in the sense sin inverse L beta by A2. Sin inverse L beta by A2. Right? Now what is the phase difference between A and B? Pendulum A and B differ by a phase of pi 2 minus pi 1. See here I am saying pi 2 is greater than pi 1. No, phase acquired by beta is more than that of phase acquired by pendulum B is greater than that of pendulum A. Now phase difference delta pi equal to pi 2 minus pi 1. Pi 2 minus pi 1. That is pi 2 minus pi 1. So pi cancel. We left with sin inverse L beta by A2 plus sin inverse L alpha by F. That is sin inverse L beta by A2, otherwise A1, plus sin inverse L alpha by L alpha, otherwise see pi 2 minus pi 1. Pi 2 means here to there, pi 1 means here to there. So this term minus of this term, minus of minus cancel, here minus of minus plus. So sum of these two terms, that is sin inverse L alpha by A1 plus sin inverse L beta by A2. So this is the phase difference of these two pendulums. Okay friends. So thanks for watching. Bye.